The raw data is inside the My Documents folder there. I did not load it into GeneMapper on those. I mean, GeneMapper is open, so all you have to do is, you know, add samples to project. You'll see 2 runs for yesterday. The first one is the first injection. The other one's the second injection. There was only one sample that I had a bad injection on, sample number 6. So whoever had sample number 6, if you all would like to see that data, then it should be good in the second injection, but that was, nope, that's not bad. Okay, that's not the right one. Oh, that's 15B, I'm sorry. Sample number 6. Yeah, I mean, it would have been see, it started off okay, but then it failed all that. So that was just a bad injection. I mean, that has nothing to do with the MinElute or anything. But if somebody wants if y'all want that data, those run folders to take back with you, I was gonna find out if we can get them onto your thumb drives or not, but we'll see. If maybe during Josh's lecture I can just stick stuff onto the thumb drives that you'll already have, and I can just give you the run folders. The pages in front of you with the numbers are for the original run, so that you'd have an idea of which samples you did, and that original run is 82109. It's also, that run folder is also on your computers in the My Documents folder. So if y'all want to see what it originally looked like, what I can do real quick is just, I mean, y'all can feel free to look at your computers. I can pull up just some of the original run here so you can get an idea of what the original peak heights look like. Yeah, we have 4 computers, so y'all can split up into groups of 3. Y'all can do that at any time. Y'all can do that now. Y'all can, if y'all want to look at some data for a while.
Have Rob bring you through some data and then start playing with it yourself.
If y'all want to split up in the same groups y'all had yesterday when y'all were working, that would probably be good, because then you'll probably remember, you know, better what y'all did. Because I know some people, I looked at some of the people who repeated it. Did y'all have like A and B? Is that how y'all numbered it? I looked at one worked and one didn't. So I'm curious to see which one was the one, which one is the one that worked, which one's the one that didn't, because I'm curious now that I saw that one actually did work. So I'm not sure. Y'all would know better which method it is that worked and which method didn't. So I'm actually very curious about that. So I can just give you an example. This is what some of the original data looks like. Let's just do. So, I mean, the peak heights aren't exactly low, but this was my approximate 0.1 nanogram per microliter. So, not that you'd actually want to MinElute this. Most labs probably won't, because everything here, I believe, is even over 150. And you will see that sometimes you may get some peak height imbalances. Well, that's not too bad. But you do see some peak height imbalance. But I did not lose any. I did not actually lose any peaks. Yeah, I didn't want to. So this is what the 0.1 nanograms look like originally. So we're looking at peak heights on heterozygotes about the 200 range, some as high as 400, and maybe the homozygotes between 5 and 700. At 0.05, let me just grab some of those so y'all can just get an idea. Okay, at 0.05, you see they go a bit lower. We're going on to 94, 44. You'll also start to see, I mean, you have some that's practically just about dropping out. I mean, that's pretty low there. So the peak height ratio is obviously way off on the 0.05 ones. So the 0.05 is when I started to see a lot more stochastic effects occurring. I should have done 200. I'm trying to see if I have any dropout. I know in some of them I had dropout, like this one's really low. I mean, that would probably be considered dropout. I mean, most people won't detect that. So, I mean, you have an idea. So the 0.05, we're looking at anywhere from the 30s, 40s, 50s, all the way up to maybe 200 approximately. So when you look at if you just want to look at your data that you ran yesterday, at least you'll have an idea of what the peak height difference is going to be, what your fold increase is going to be. So what I can do now, let me pull this one back open. And I won't say names of whose samples are whose or anything like that. But y'all can have an idea of when you look at the numbers, because I don't even know whose numbers are whose. You all know, what numbers are yours. I don't even know off the top of my head. So if anybody, let's just look at a typical one. I know the early numbers were definitely the 0.1s. So this was a 0.1 here. And as you can see, your peak height's now 1,500, 1,200, 1,000, 1,400, 1,900, 3,000 on that 15 down there. So yes, so the good news is it worked. What I wanted to show, I remember there were some people who only had me add 1 microliter. And I know that was A1, B1, C1, starting from, I believe, D1, because I injected those, I did those first. So you'll see the 1 microliter, there's a big difference. Let's see, 500. You still did get an increase because it was about 200 before. So now you're looking at, it maybe doubled it in some cases. Is probably what you got. So you did get an increase with just adding 1 microliter. Yes, this was a 0.1 nanogram to start with. Well, no, wait, number 51 actually wouldn't have been a 0.1. That would have been a 0.05. So this would have actually been a 0.05. So it actually gave quite a big increase for the 0.05. And I was only adding 1 microliter. This is just a lot of pull-up from the Liz.
Did you add 1 microliter for all of them, or
no? Just there were like 2 people. Who were the 2 people? Okay, 1, and there was somebody else who said that they'll only add 1 microliter, so they wanted me to just add 1 microliter. Okay, so do you remember what samples were yours? Was 50?
I was 51.
You were 51, and then
I was 53.
Okay, so we can just 51, but didn't y'all have 2? So 51 and which else?
22, I think.
Oh, wait, you know what? I don't think I told you that on the other ones. I had 9 and 40.
Those are the ones that you had me add?
Yes.
No, let me do, let's see. And somebody has 92, which that's probably my fault the way I wrote it on the actual tube, because I didn't have 92 samples, so I'm not sure which one that correlates to.
What was
So 51 and 22, and then 9 and what?
40.
That's 40. And that's file number 9.
There it is,
Oh, there it
49.
is. Okay. Okay. And let's zoom back to about 5.
what was the volume used for the remainder?
It was the full volume. I used the full volume basically, and everything that was left I put in for the remainder ones. So this was number 51 we showed before. As you saw, the full volumes ones, we got up to like 2,000, 3,000 RFUs. Here we're getting about anywhere from 380 something. We have 600. We actually have something in the 1,000, the low thousands, 1,133 and 1,155. Number 22. This would have been a 0.1. And these are more 700, 600s. We have something in the 1,000, 1,300 mark. Number 40, I believe that's a 0.05 also. And that one doesn't look, see CSF is not really that high. I'd have to compare it to the original data to see where CSF was in the original data. And that's something that, we can give you the data. And if you wanted to go home and look at what the original CSF was, maybe it was very low into the baseline. Maybe it appears to be dropout. And so it only increased a little bit. Yes.
What amount of your amplicon are you adding in the original run? Like for your original data, what's your volume there? You're not
It's just a regular 1
Just
microliter.
one
Yeah.
Okay.
Because if you add all, I showed you that yesterday, it totally suppresses everything. So you can't even do you can't do a comparative even 10 microliters to 10 microliters because it just will suppress the size standard and everything ends up getting suppressed.
And have you looked at it by increasing, not taking it to such an extreme where you're going from 1 to the max of your amplicon, but increasing your amplicon to like 2-3 microliters?
Yeah.
Is that what you showed us?
Yeah, we had some data like on that where I only took some of my amplicon and ran it through the process, and then I took all of my amplicon, ran it through the process, and only added some of it onto the instrument. And I think that's what you're seeing here with the people who only added 1 microliter. They may be still getting an increase, it's just not as high. Now this one, number 9, was originally a 0.1, and this is extremely high. Yes.
I wasn't sure. I see that there's a lot of pull up from the orange channel.
Yeah, there is a lot. I know. I'm noticing
Do you find
that.
that you have to reduce the amount of Liz that you add because there's less species competing for injection, or is it just a bad spectral?
It may be just a bad spectral. I've not seen this much pull up before, honestly. I've never had a pull up problem coming from orange with MinElute before. So this isn't something I've like seen consistently.
Okay.
This is actually the first time I'm seeing all this pull up.
What numbers did you have?
I thought it was 51 and 22.
51 and 22?
And you had number 9?
Yes.
Did any of y'all do more than 1 wash?
We just did
Yeah.
1.
Did you want?
Yeah, we did 2.
We did 2 on.
Okay, so which ones? Let's look at some of the ones where you did more than 1 wash.
I did 2 and 41 on top 2 before this data set.
It's actually like 50 is pretty low. Yeah.
That sound right? 2 and 41.
2 and 41 were yours?
The peak heights of
No, yours was the one that you just let it ride, as I recall. Okay.
But it worked.
Let's see.
I think if you.
Let's see if I can find. Maybe if I do just now. That might help me out. There's a 2 and 41. Whoa, didn't mean that to happen. Why is it? Okay, let's look at 2 first. Okay, so this. Do you mind if obviously if I tell everybody what happened?
You're gonna rat me out?
Oh, we do have
That's
a little.
fine.
We have a little problem with CSF though. It's going off ladder. That could be the ladder. But basically with this one, they forgot to do the, after you do your PE wash for 1 minute, you're supposed to do your 1 minute dry. This was actually, this forgot to do the 1 minute dry. And still we got an increase in peak heights. I mean, this would have been 0.1 nanograms. So I mean, this actually went up by, 200, maybe like 5 to 10 fold. So actually still got a big increase. Let me look at number 41. I gotta figure out, but number 41 is not as high. There still is an increase. It shouldn't be the wrong ladder. I'm just curious as to why I'm getting off ladder alleles. Let me look at the raw data real quick. The raw data looks fine. And why? It's just basically just outside of the bins they're supposed to be in. And it's just the larger loci that's happening too. I wonder if that is somehow a byproduct of, because I didn't see that. I mean, I just was able to take a quick glance at the samples today, but it's not happening in anybody else's. So I wonder if that is some sort of a byproduct of the fact that we didn't get all the washing done. I mean, yeah, I'm just curious because that's something that I didn't see. I'm not seeing anybody else's stuff going off ladder on those alleles, those markers. Now, the other people in that group who altered stuff, do you remember what those numbers were? Are those ones where I have an A and a B? So like 33 and 33B? Was that something? Now, which one was the one? Because one, but then again, you're seeing it happening again. And then this one, whatever 33B was, that didn't work.
The A was off the old column.
Okay, so the A was off the old column, and then the B was when they had,
We redid it.
when you redid it. Okay,
Right.
so the B, so obviously that process of redoing it isn't actually going to fix it. And then it looks like what we're seeing is a side effect. If you don't do that PE drive-through and you do run it, you will get an increase, but you seem to lose your Lars or loci. I mean, not lose them, but they're not lining up. That's an awful allele. And I've never seen this before because I've never actually done this before, but it's actually a good thing to see because now I know people talking about for troubleshooting. If you saw this, if somebody's MinEluting and every time they were getting this result where they're getting everything, but just the last couple, just those two loci for some reason are off ladder, then you may ask them, hey, did you do your 1 minute dry spin?
Did you try reanalyzing that with a ladder that's closer to it only?
Well, this is actually pretty close. Like the number 2, that hers was like right next to the ladder.
It was?
Yeah.
And they were injected at the same time?
Yeah.
But it's averaging, it's using the other lavaders to size that, so it's probably just a sizing problem.
I mean, I only have 2 ladders and I only have one as a ladder. I can average them both, but this other ladder was put at the end of the run.
Right. And so if you took that ladder out, hers might size
It's actually
better.
only using one ladder.
It is?
Yeah, I'm only using one ladder. I only have one. I only have one ladder. I have 2 ladders, but I've only selected one.
I see.
But the number 2 was actually, it was the number 2 was actually very close to the first ladder.
Which sample was that? That's not sizing right?
33 and 33. It was 33 that wasn't sizing right. Now, what was the other one? Was there like a 16? Who did 15A, 15B, 16A, 16B? Okay. So I think it's the same thing with those also. Now, the D2 actually sized here, but the CSF didn't. And the A worked. And the B, well, the B actually did work, but once again, you're getting the off ladder coming up on the larger loci only. So like I said, that's something new. I had not seen that before. And then this is 16B. Once again, you have the off lateral alleles.
Rob, when we made both of them ladders, they typed.
Oh, when you do, oh,
Yeah.
when you average the ladders? Okay.
And
But
I-
they did in the back.
I also combined both run 1 and 2
I did
Oh.
also.
and
Yes,
just
I did.
labeled every ladder and everything's fine.
Oh, okay. I know some labs don't. I've encountered stuff where some labs won't average ladders, so some people do and some people won't. Yeah. So I didn't know which, so I just chose not to.
We just import one.
Right. See, some labs just use one ladder, and some labs, yeah, don't. So,
4 and 44 were the ones with 2 washes.
okay, let's look at those real quick. 4. Okay, so. Now, were there any that, did you do all of yours with 2 washes, or did you do one with 2 and one with 1?
We did those 2 samples with 2
Two.
and our other samples with 1.
Okay, what's one of your other samples?
50,
Let's see what 50 did. 50 is about the same peak heights as the one with 2 washes. Yeah, and then, yeah, we want to look at the ones that had the chi-cube stop too, because I'm not sure if those came out.
You could possibly encounter.
I mean, it's not that big of a deal because it's
Let's see, number 44.
to start seeing.
The 2 washes doesn't actually appear to have made much of a difference between the ones that had the 2 washes and the one that had the single washes. In peak heights, that is. But once again, you'd have to see what the original data looks like. Actually, number 4 probably would have been a 0.1 nanogram sample, and number 44 may have actually been a 0.05 nanogram sample originally. So we'd have to basically, you'd have to look at the original data, and that's why I say I'll give you all the run folders to take home, so you can actually look at the original data and then do a comparison and do your average fold increase. Now, which were the ones where the chi-cube had some problems?
At 7 and 39,
Were both of them?
they were on the kite.
Well, we still got something. However, it doesn't really look like I don't know if this is actually an increase. because your original data was about, for this would have been a 0.1 nanogram sample. So the original data was probably about this high, or maybe even a little higher. So I don't know if we actually got an increase off of that. And then what's the other one, 39?
Yeah.
Ooh, I didn't get anything off that one. Now, who ran the chi-cube, the other chi-cubes, and that didn't have any problems? What samples did you all?
58 and 36.
So 58 would have been a 0.05. That's actually. So that would have been a 0.05. So this would definitely be a fold increase for the 0.05. You'll see some peak heights, but you'll see your imbalances. Once again, if you have to check the original data, but if you had an imbalance before, you're going to have the imbalance after, especially if you have a big imbalance like this. I mean, if it was just slightly off, it may just change due to injection. But when you have a large imbalance, it usually tends to stay like that. And this was 58, the other one was what, number 36?
Yes.
Which I believe would have been a 0.1. Okay, so number 36, this was a 0.1 nanogram sample, and you can see the peak heights are a lot higher. I mean, this is like 3,000 nearly RFUs, and this is with the chi-cubes. This is actually really good data. It looks like I'm thinking it's probably close to more than a 10-fold increase for this sample, because I'm pretty sure we didn't have anything that was at 400 RFUs at 0.1 nanograms to begin with. And now we have something at 4,400, so, and 3,300 and 5,200 and 5,100. So we actually have a lot of high data on this sample with the chi-cube. Anybody else ran on the chi-cube?
It was 13.
13?
That was the broken chi-cube.
Oh, okay. What about the one that worked?
57 and 35.
Yeah.
Okay. Let me go back. So 57 would have been a 0.05. I've got. Is that? Why do I have two things labeled 57? That might have been my typing. Let me check something. So 57 would have been a 0.05. So this is a fold increase for 0.05 definitely. And number 35 would have been a 0.1. So we can look at number 35. And you can see the 0.1 again is very high. But you'll see, as you get, obviously, when you start to raise your peak heights, your baseline starts to get raised, and you start to see a lot of these, raising your baseline. They're OLs. Luckily, these are OLs, but then you have this 9 getting called here, which could be actually maybe pull up into these. And that's why the only thing is with mixtures, you have to be careful, because you do get a lot of artifacts, and not artifacts, but problems associated with high-level data with mixtures, so your miner may give you trouble to interpret. Like this is probably definitely pull up into these.
Maybe I'm missing something, but I'm trying to look at the original data,
Okay.
and I can't tell which sample's what.
Which samples
Because there's no well numbers or anything.
in the original data?
Yeah, at least I'm not seeing any, but.
Let me see. Is the
Where's my
do
sample
I not have
file?
maybe the sample file, is the sample file not?
No, and I don't know how to do it.
If you go to table setting editor and go to samples and just click sample file,
Okay.
and then that should fix it.
Okay, thank you.
Well, yeah, this is back to the original data. What was, somebody give me a sample number. What was some of yours, Janaki, that worked? That was,
Chi cube or manual?
no, which Chi cube did you use? The one that,
The working one.
okay, so yeah.
58 and 36.
Okay, 58 and 36. Okay, let's look at 36. Would have been sample G5. So this was the before of G5 of number 36. So we're looking at, I mean, we could try and remember this if somebody wants to write them down, but like 200s, 300s. Okay, we have something as high as 700 on a homozygote. Nearly 400 on that heterozygote. So a lot of 200s, 300s is about the average of what we're looking at. And now let's look back here at number 36. So now we're looking at like 3,000s, 5,000. So we had from 200s and 300s before to about high 2,000s, 3,000s. So it's once again, it's going to be approximately close to a 10-fold increase is what you're going to see with the chi cube washes. I mean, when I did those average fold increases, I did the average for every locus, for all the markers for that on one particular profile. So you'll see that some may not increase quite as high as 10-fold, and some may be a little over 10-fold, but when you average them out, you get approximately a 10-fold increase. Is there anybody else's data that y'all want to look at? Anybody that did anything differently? I mean, we can go, I mean, if y'all want to just take some time, what I can do, perhaps, if y'all want to go through your data, and then I can pull up maybe the original data on this screen, so that way you can like look at your original data, and then I can just like, if you tell me what your original ones are, I have the sheet here, I'll find it for you, and then you can look at your MinElute data on that computer there, so you can do your direct comparisons instead of trying to move between projects.
Can you create a project that it combines the two data sets? You compare them side by side?
I can, let me see, but actually, I don't know if that will, how that will work with the, let me see. This should be everything here. I don't know if this ladder will work for everybody, but we can try it out. Let's just do another ladder. Why is it saying that?
You have to analyze again.
Yeah, well, when I hit analyze it,
You hit plot window instead of analyze.
Okay, so we could probably try and bring up two samples side by side. Anybody have any suggestions on any two samples they would like to look at? Who did the one wash again? Or what sample was that? I mean, sorry, the 1 microliter. And what sample was that?
9 or 40.
Okay. So you'll see that's basically the one on the bottom was the original one, and then the one on the top is the MinElute. So you see not quite a tenfold increase. Yeah, it looks to be it's definitely less than a tenfold increase, especially when you look at the larger loci like CSF. Then when you look at here, 500 to 4,000, so it's not, but obviously it's still giving you a large peak height, and this was only using 1 microliter. So like we were saying, yesterday with the whole validation, when you all are validating this, you all don't have to add all your volume. You can, if you have data, like this data is actually, this is actually very good. This is actually better than what I had seen originally when I had only added the 1 microliter. I mean, I was only seeing like a fourfold increase or something like that. This is probably maybe 7 or 8, you know what I mean? So it's actually very good.
When you said you added the full volume, that was the 10, but the robot gave 15. Did you add all 15?
Yeah, the robot gave all 50. Yeah, for all the ones that whatever full volume I got, I added all those. And then there was just 2 people who specifically said if you could only do 1 microliter because that's what their lab would do, and they probably wouldn't want to change that. So this is with not changing it. And like I said, this 0.1 nanogram, I mean, I think everybody would probably use this data. I don't know if any labs have anything that wouldn't. I've heard of a lab, I don't know which lab, that's 300 RFUs, somebody once said. But I mean, I don't know which lab it was, but a lab that either I visited or dealt with, they had they needed it to be over 300 RFUs or something fit to be called. So like a lab like that, and so this sample obviously wouldn't even work for them, the 0.1 nanogram, but obviously this would, the cleaned up sample. Is there anything else? And what about a 0.05 nanogram sample? Who had one of the later number samples?
1 microliter?
Either one, just to see what the 0.05. I'm looking to see if I can get some dropout.
I was number 51, and that was at 1 microliter.
Yeah, that should have been a 1 microliter. Why am I showing 2 51s? I only have supposed to have 151. And that was, you only added 1 microliter?
No, I asked you to add.
Oh, well, yeah, maybe.
I've got my courtroom answer on.
Okay, number 51 was G7. Okay. Oh wait, no, that's not the right one. Just 1 second. Oh, there it is. G7 and number 51. Okay. So this is the before and after. The top would be 0.05, and then the bottom would be 51. So this is 0.05 nanograms. Obviously, the top one, a lot of labs will not be able to use that data at all. You'll be able to use some of it, Like you could probably get the 12 there, and you can get the 33.2 there. I don't know what your calling thresholds are. A lot of labs are at least 100. Some labs I know go down to 50. But you know, what's like a consensus in the room? Would you say your calling thresholds are like?
We have two, so the limit of detection is 50.
Okay.
But then our stochastic to use something statistically is 230.
230. Okay.
125.
125. Okay.
150.
150.
75.
Okay. So anywhere from 75 to maybe 250, 300, you know, we'll all be in there. So, I mean, if you look at something like this, I mean, for those of you who are at, if anybody's at 150, I mean, this top profile is totally not usable. But this to me is the cases where, you know, where MinElute is easy to implement now, because this is something where I can see the entire profile. I can actually have it called by gene mapper. So it's actually, I know that my suspect is an 1115 at 32.2, 33.2, but my protocols say I need it to be over 150 RFUs before I can make an allele call. You run it through MinElute, you get the bottom, and now you've got everything everywhere from the lowest is what, 367? Oh no, sorry, 331 is the lowest. Is the lowest RFU height. And this is where it's sort of like, it's just an easy thing because you can confirm that your profile is the same profile. You can confirm you have no dropout, you have no drop in, because you can actually see the profile before. And this is what when I talked about when you know, you have those cases where, and as you can see, the imbalance here, notice you still have an imbalance here. I mean, it's still called, I mean, it's still at 518, so I mean, it's still a nice peak height, and before it was at 73, but notice that how like the extreme imbalances will actually stay, whereas like a smaller imbalance may actually tend to go away. That could just be due to, I don't think that's anything to do with MinElute, that's just due to, you know, if you inject the same sample 3 times, you'll get 3 different peak heights. You've got 3 different peak height ratios on a heterozygote. So I think that's what it is. But once again, this is like where I think is the easiest way to implement MinElute quicker. As you know, this is obviously before you go into the interpretation of if you have nothing and you get something, and you know how are you going to deal with that. But as a way to easily confirm that you're not producing DNA out of thin air, that this is actually the profile that you expected to have. It's just that you couldn't use it before. Now that is probably from Liz, that 25. Oh, I don't have it listed. Yeah. Yeah, that one that looked like an extra peak there was actually pull up into Liz. Now, no, that's still, now maybe we should look at, I was going to actually look at the Liz between the cleaned up and the non-cleaned up and see if we're getting, it seems like when it's cleaned up, Liz is actually getting boosted quite a bit. Now I haven't experimented with reducing the amount of Liz that I put in, amount of size standard I put in, because I know that that is actually a method that some labs use to actually boost the signal of the actual data. But you're talking before, my Liz was at maybe 2,000, and now it's practically off scale at 8,000.
If you actually turn on the off-scale peak indicator, all of those peaks show the camera
They're all off
saturated.
scale. So Liz is going off scale with the cleanup process. So that may be actually something that, with another thing to implement into the lab is when you're doing your validation, is to check and see how high your Liz is, and after cleanup, if it's actually getting higher, then you may need to actually add less Liz when you're doing a cleanup process. As
How much
opposed
Liz did you put?
0.3 per sample, which is what the recommendation was, is what it says formide 8.7 and 0.3 microliters of Liz per sample. So it's the same amount of Liz I put in the top sample is what I put in the bottom sample. It's the same formide to Liz mix. So it's something, it's obviously it's another byproduct of the cleanup where you're getting a better signal. You know, it's cleaning up all the junk, so you're getting what you actually have going through your instrument now is really what you want to get hit with that laser. You You're not getting the random dyes and the random dye blobs and the excess primers getting hit with that laser and getting excited and being detected. You have whether it be the size standard or the actual DNA that you want the laser to excite. That's what's getting hit.
I think maybe the reason why previously you didn't see the Liz being this high is because this is where you only added 1 microliter of the cleaned up amplicon.
That's true.
And the others you were adding 10, so those were competing with the Liz.
Let me see.
Injection.
Let me just grab a sample. I'm just going to grab one randomly. 39. I don't know whose that is. Okay, well, let me look at the Liz there. Oh, that was one of those that probably didn't work, so probably not be a good one. Okay, let's 24. 24 sounds like it worked, yeah. Okay, so the Liz does not look as high. No, actually the Liz is not as high for there. So yeah, you're right. It's like when you only added 1 microliter of your sample, the Liz actually got more than when you added 10 microliters of your sample. So yeah, it's probably as a competition thing. So there's a lot of aspects, little aspects of this procedure that you'd have to put into place, especially during your validations, to decide what your lab is going to do and how many washes you want to do, how much Liz you want to add, how many microliters of your cleaned up product you want to do. Do you want to clean up all of your product? Do you just want to clean up some of your product? All those things are going to take into effect what kind of fold increase you're going to get in the end. And then that's going to then tell you, well, now what am I going to use this? What kind of samples am I going to use this on? If I have a peak heights in the 200s, can I use this or am I going to off scale it? You might say, well, yeah, 200s I can. If I have a peak height, if I have a major that's at 2000 RFUs, then maybe this isn't the best thing to use, because then it's going to shoot that major up to off scale and mess up my minor. So all these things will be things you'll have to look at in your validations.
Did anyone do 2 manual washes?
Yes.
We did. Yeah, that was 4 and 44.
I wonder if we want to compare maybe 44 to the single, or maybe do another one with a single wash?
Yeah, 50. 50.
And 44, just to see if there's.
Let me look at 44, and let me look at 44's original data, which is G6. Okay. Okay. So this is the original 44 data, because it was a 0.05. And this is it after 2 washes. So you can see that these are somewhere it's kind of close to a 10-fold increase. Now notice these 2 markers down there, D7. I mean, you're talking about something that's at 28 RFUs, and the other one's at 42 RFUs. Now we're going to 1300 and 500 RFUs. And this is, once it shows the power of the system, but then also shows into your interpretation procedures, because, I mean, honestly, not many people would look at something at 28 RFUs at all. And now here, after you do MinElute, it's at 1300 RFUs. You cannot ignore it now. It's like, well, it's definitely there. So that definitely is showing actually the power of the system. But if you want to compare, so it was number 4 and 44. So let's compare 44. And did anybody could I get like a 0.05 or a high number sample that was done with 1 wash?
The 50.
50, okay. Okay. Oh, no, wait, I still have that 0.05 listed. 1 second. So 2 versus, so 50 was 1 wash? Oh, 2. 50 was,
It was 1.
50 was 1 and 44 was 2. And actually the 50 looks better in this case. Peak heights are a lot better with the 1 wash. Yes, definitely a lot better than with the 2 washes. Now, I didn't see that when I did it, but
Melissa, do you have
What did
that sample, what was your other one, it was the 0.1 nanogram that you did 2 washes on?
4
4.
and 5 would have been a 1-wash one.
Oh, okay.
Down in trials.
So 4 was 2 and 5 was 1. Okay, 4 and 5. Well, and now in this case, it seems to be the reverse, where number 4 was 2.
4 was 2 washes.
4 was 2 and number 5 was 1 wash, and 4 is definitely higher than 5. 4 looks like approximately double.
But what was the beginning data, the
Um,
original?
let's see. I could probably throw that in there too. Let's look at the beginning data for number 4, which would have been G1. No room. But this is the beginning data down here actually. But let's okay. So the beginning data for number 4 was at 200. It went up to 1800, and this was what 2 washes. 178 went up to 1400. 200 about went up to 1600. Come on. About 298 went up to 2800. 600 went up to 5600. 473 went up to 4100. So it's almost a tenfold increase with that. Now let's look at number 5 and the beginning data for number 5. Number 5 would have been H1. Okay, so the beginning data is 150, then it went up to 766, 163 to 895.
This one's 1 wash.
This was 1 wash. So the beginning data is probably about the same, but obviously the increase was a lot more. What I want to do is let me just look at something since we've noticed stuff with Liz. Let's look at Liz between 1 wash and 2 washes and see if it affects the Liz in any way. Because 4 and 5, we added all. You hadn't told me to add less, right? Okay. So 4s with 2 washes and 5s with 1 wash. Is that correct?
Yeah.
Okay. So it looks like the 2 washes, the Liz got higher. The lowest peak is about 1500 RFUs, whereas over here the lowest peak is about 400. So that's, once again, is something y'all experiment with the number of washes y'all do. And I believe Matt and Josh were saying that the Kaya Cube can actually be made to do more than 1 wash. That would actually be a pretty easy fix to have a program installed there for it to do more than 1 wash, which is something that, I mean, I personally would like the Kaya Cube that I have here to probably do more than 1 wash also, because the Kaya Cube washes, to me, because it's doing the pipetting for you, you didn't have that much variation between the Kaya Cube when you did samples with a Kaya Cube than when you did it manually. It seemed like I'd shown you all that data yesterday, that the fold increase for one thing was like 11-fold, the next one was like 16-fold. When I went, when I did the manual, but with the Kayak it was 9 point something full and 10 point something full. So since the Kayak might produce a more precise pipetting, and it would be curious to see if we did more washes on the Kayak exactly how that would maybe boost our data even more, but keep it more precise. And I know we had a little problem with one of the Kayak but the one that y'all did use, I mean, did y'all find it was pretty simple to use? I mean, as far as instrument goes, I mean, like I said, the perfect thing for that, I think, is you have your samples in there, you close it, you're setting up your 3130 with your formite and all that, and then by the time you have all that done, it's done. I need just somebody grab your samples out there, load them in, how much ever you decide you want to load, and you're good to go. So it's something that's one of the features about it that I like. You can actually just set up your samples in there within it'll be in the same room, and then just go ahead and work on your stuff for your instrument and get that going. Yes.
The volume left in those sample tubes, you said that was common?
Yes, that was common, and Matt was going to look into that. He said that it was something to do with how deep it goes in. So that is something that he was going to see if there was actually a way to rewrite the program to see if it could go down deeper, how deep the pipette tip's going in. But yes, the first time I ever run the Kayak that kind of was like, what's going on here? And why do I have volume left in my sample tube? And I thought for some reason something didn't work. But then when I ran my samples, I got nearly a 10-fold increase. So I was like, well, it's working. So it's not like it's not working. I mean, so it's not like it's leaving sample. But what Matt was saying is that it doesn't go all the way down.
Yeah, and that's actually after it adds, I think, 600 microliters of buffer. So it's only, according to our technical support team, it's only about 4% of the whole buffer. So it's real minimal. I was a little nervous too when I first saw that because it looks like it's maybe 25 microliters or so. But they said it should only be about 4% of the final volume after the additional buffer is added. And then remember there was the 75 microliters of buffer that was added. And then there's another, I think, 600 microliters of buffer that's added on top of that. So it's a smaller fraction than it looks of your total sample.
I guess that's better than having the pipette smash into the bottom.
Yeah,
Yeah.
Right.
And I think what we're going to talk to them about is see if we can have it go lower, a little bit lower in the tube to get as much of that sample as possible.
Yes.
So with the Kayagen robots, you actually can't do any adjustment as an operator to we have different types of robots, so I've never worked with Kayagen where we actually can make a determination on well percentage of how far it's going down, if they're going to liquid sense, if they're not. So we can't do any adjustments really to that, right? It's a program coming in.
Platform of ours, you can't. For some of our other platforms, you can. But this one's pretty much, you don't have any programming capabilities as a user. But what you can do is email our programming department, and they can set up all those variables because they need to make sure everything will work within that protocol that you might be running. And so they test all the different variables to make sure it fits into the protocol that you want to make those changes to. So I'll talk a little bit more about that in my presentation.
Okay. Is there any other data anybody wanted to see? Any comments on the system and how when you did it yesterday? So you can think it was a pretty easy thing to do manually and with a robot. I mean, you can see manually it's pretty quick and it's pretty easy. That's why I said in my presentation, training someone on this, I mean, it's minimal. I mean, honestly, I mean, if you can pipette and operate a centrifuge, y'all can train, any of your analysts will be able to do this. And you could probably train somebody and have them do a competency on it the same day. That's just how easy it is to do. And with the robot, I mean, it's really just once you have got everything loaded correctly, it's just pressing the buttons on the outside, and then it's good to go, and it does it all by itself.